Hello everybody, welcome into another lesson. So today we are starting the unit on 3D solids. We're going to talk today about cubes. A cube is a type of prism, which the next lesson will be on prisms in general, but today we're starting with the easiest type of prism, which is a cube. A cube is your classic type of box. It's an even box where every face of the cube is a square. You have your two bases, the top and the bottom, those are squares. So you have every cube has two bases, and then on the sides it has four faces. Of course, a square has four sides, so if you take squares and connect the top base to the bottom base on each side, you would have four faces. So a cube total has six faces, which would be two bases and four faces. It has a total of six sides, six faces. So, having said that, there are a couple formulas here. First, let's talk about volume. So what is volume? Volume in general is the capacity to be filled of a solid. So, for example, if you're trying to fill a swimming pool, or you're trying to pour cement or something like that, you're going to use volume to fill something. You'll figure that. You'll use volume. And volume is usually used in terms of cubic units. Since the base of a cube and all the faces of a cube are a square, the volume formula is derived from the area of a square. The area of a square, as we recall, is the side squared. Well, since every single side length of a cube is the exact same, to find the volume, you just take one of the sides and raise it to the third power. And then we have what's called the surface area. The surface area is the total coverage of the outside of the object. So if you're looking to paint a house or something, you're going to want to find the surface area of the house to know about how much paint you want to get. That's where surface area comes in handy. You're not going to pour paint into the whole house. That would be the volume. I don't think you'd want to do that. You'd want to find the coverage of the outside of the object, which is the surface area. And the surface area, of course, you're going to take the area of one of the squares, which is a side to the second power, and then you're going to multiply that by 6 because there are 6 faces that are squares. So the surface area of a cube is 6 times a side squared. So we'll do some examples here. Let's see, what do we get here for the first one? So we have a side length of 3. We need to find the volume and the surface area. So to find the volume, of course, you're just going to take one of those sides. You know what? Let's give it a unit here. Let's say we have a length of 3 feet for this side of the cube. The volume, of course, you would take that length of 3 feet and raise that to the third power. Well, 3 to the third is 27, and then feet to the third is feet cubed. So the volume of this particular cube would be 27 cubic feet, or 27 feet cubed, however you'd like to say it. Now, we want to find the surface area. The surface area, of course, since there are 6 even square faces, that's going to be 6 times the length of the one side of the square of 3 feet to the second power. Well, 3 to the second is 9, so you'd end up having 6 times 9 square feet, which would give you a total of 54 square feet for the surface area of this cube. So your volume is always in cubic units. Your surface area is always in square units. That would be the answer to those. And I got more examples here. This isn't going to be a very long lesson either, because cubes are quite honestly very easy to deal with in terms of as far as what to do for surface area and all that. Okay, let's see here. Let's say you have a length of 2x. So a side of the cube has a length of 2x. Well, let's go ahead and go for the volume first, right? The volume is going to be equal to, of course, one side of that cube, which would be 2x raised to the third power. Well, 2 to the third, that's 8. X to the third is just that. So the volume of this cube would be 8x to the third. Now we just need to find the surface area. The surface area, of course, is equal to 6, since there are 6 faces, times a side squared. So it would be 6 times the quantity of 2x to the second power, which then would turn into 6 times 4x to the second power, which in turn would give you 24x to the second power for the surface area. So you get a volume of 8x to the third power, you get a surface area of 24x to the second power. Alright, we're going to change this up a little bit with the cube. We're going to work backwards a little bit. This time, we have the volume equals 1,000 cubic units. So the volume, we'll say 1,000 meters cubed. I'll put a unit on it to make it easier. So the volume is 1,000 cubic meters. We need to find the length of the side and then the surface area. So if the volume is a side to the third power, that means a side is the cube root of the volume. So the length of a side is going to be equal to the cube root of 1,000 meters cubed, which the cube root of 1,000 is going to be 10, and then the cube root of meters cubed is meters. So the length of a side of this cube is 10 meters. Now that we know a side, we can find the surface area. So the surface area, of course, is equal to 6 times the length of the side, which in this case is 10 meters, raised to the second power, which then would give you 6 times 100 meters squared, which would give you a surface area of 600 meters squared. So you find a side to be 10 meters, and then the surface area would end up being 600 meters squared. Alright, this time we're given the volume would be 64 centimeters cubed. We'll use centimeters for the unit. So we have a volume of 64 cubic centimeters. We need to find the length of the side and then the surface area. So to find the length of the side, you'll take the cube root of your volume, which would end up being 64 cubic centimeters. Well, the cube root of 64 is 4. Cube root of centimeters cubed is just centimeters. So the length of a side of this cube is 4 centimeters. Now that we know the length of the side, we can find the surface area. So the surface area, of course, is equal to 6 times the length of that side, 4 centimeters to the second power, which would turn into 6 times 16 square centimeters, which would end up giving you 96 square centimeters for the surface area. So length of a side is 4 centimeters. The surface area would end up being 96 square centimeters in the end. We're going to change it up for the last 2 exercises yet again. We got 2 more exercises here. This time it changes because actually we only have 1 more exercise, then we're done. Okay, that works. 1 more exercise, but I think you'll get the gist of it. So the surface area is going to be equal to 150 meters squared. So this cube has a surface area of 150 meters squared. We need to find, of course, first the length of a side, and then find the volume of this cube. Well, if we remember, the surface area is 6 times the side squared. So what you're going to do is take 6 times the side squared, set that equal to what your surface area is, which is 150 square meters. And then we'll get s squared by itself. So s squared, you divide both sides by 6, would give you 25 meters squared. And then, of course, to find the side, you just take the square root of both sides, only the positive square root, since we're talking about lengths. The length of the side would be 5 meters. So now we know the length of the side, we can proceed to find the volume. The volume, of course, is just taking your side length of 5 meters, raising that to the 3rd power, which 5 to the 3rd is 125. Meters to the 3rd is just that. So the volume of this cube is going to be 125 cubic meters and a side of 5 meters. So that's it for cubes. Next lesson we're going to talk about prisms in general, such as rectangular prisms, triangular prisms, and maybe even some trapezoidal prisms. So I hope everyone has a great day. Happy Thanksgiving to my American friends, and I will see you all in the next lesson.